Hello, everybody. Welcome back to CSCI100, Lecture 14. In this lecture, we're focused on learning about destructive functions. But to set ourselves up for that discussion, we're going to go back and review a little bit of what we've learned about functions and about mutability. Our learning objectives for today. By the end of today's lecture, I'd like to make sure that you know what it means for a function to be destructive or non-destructive. I want you to understand why you would ever want to think about this and understand whether your function is destructive or non-destructive. And finally, I want you to know, given that a function is destructive or non-destructive, how do we usually use those kinds of functions? But let's start with the review that I mentioned. So context review. We'll start with functions. You might remember back to earlier lectures where we talked about functions. A function is a named block of code. So here we have a block of code. And the name here is add nums. And now this named block of code can optionally take some input, which it does here. It takes two numbers. It performs some routine, likely using that input, and it can return some output optionally. Here's a return statement here. You don't have to have a return statement, but you can, and often do. Now the inputs I want to make sure to review. We call the inputs to our function parameters. And these parameters are the inputs that the function takes. So when someone calls the function, these are the variable names for the inputs that were given to the particular function call. And so you use these values to these variables to access the values that were passed in as inputs to the function. How do we use our function? We call our function, or sometimes we say execute, by using the name of the function, and then in parentheses giving a list of arguments. And these arguments here are then assigned to the variable names that are listed as parameters. So here we called our add nums function, and we pass in the number 4 and the number 5. These are both values. When the body of the function is executed, we assign the value 4 to the variable num1 and the value 5 to variable num2. Because 4 is the first argument and num1 is the name of the first parameter. 5 is the second argument. Num2 is the name of the second parameter. And so now, for the duration of this particular function call, num1 has a value of 4, num2 has a value of 5, and you use num1 and num2, the variable names, inside of the body of your function. And here we add them together to get a result. Now, as an aside, I'll just remind you, we talked about scope. If you're curious, like how this actually works, we talked about the global frame, and when you call a function, it actually uses a local frame, a special separate page in the notebook with that notebook analogy, and all variable assignments that happen in the function, including the assignment of the parameters, happens in the local frame. And so that way, here's our little local frame. You can see here num1 equals 5, num2 equals 12. When we call max value with num1 and num2, in the local frame for this function call, while the function is being executed, we create a variable named a, because that's the first parameter, and we assign it a value of 5, because that's the value that's passed in as the first argument. And then we do the same thing for b. So b is the second parameter. We give it a value of 12, assign it a value of 12 in the local frame, because the second argument in the function call is num2, which has a value of 12. And so now for the duration of the execution of the body, we look in the local frame to get our values, to reference variables. So here, when we do if a greater than b, when Python sees this line, it needs to evaluate the expression a greater than b. And for that, it needs to reference the value of a. And so it goes to look up the value of a in the local frame for this function, which is 5. This is also why I mentioned this before, but when the function is done executing, when a particular function call is finishing, we just get rid of that page in the notebook. We throw away that frame. And that's because every time someone calls a function, they pass in new arguments. And so each function call has new kind of assignments that happen starting with brand new parameters, so brand new values. So if I were to call max value again with 100 and 200, then a new frame would need to be created, a new local frame, and a would be assigned to 100 and b would be assigned to 200. We can't reuse the old frame. So that's why we throw away the old frame as soon as the function is done executing. Now let's review mutability. What did we learn about mutability? We talked about how what it means for a data type to be mutable, which is that a mutable data type can be modified or altered. And so far in this class, that's just lists and dictionaries. So when we have some code like this, so items is a new list with the numbers 4 and 9 in it, and we call items.append. Well, first we create this new list, items equals 4, 9. So in the global frame here, you see you have items, and it points to this list over here, 4 and 9. And then when we call items.append 7, it adds an additional item to the list. It doesn't create a new list and then set with 4, 9, and 7. It takes the existing list and mutates it or modifies it. On the other hand, all of the other types that we've learned about, which are strings, ints, booleans, and floats, they are all immutable because they can't be modified. You can't edit them. They're only ever overwritten. And so when we have square equals 2 and then square equals 9, in the global frame first, when the line square equals 2 gets executed, we write down the variable name score and the value 2. And then when square equals 9 gets executed, this replaces the 2 with a 9 because a new assignment here happens. We assign a new value, the number 9, value 9, to the variable score. Whereas you can see up here, no new assignment happened. We actually modified items. We got items and we did items.append 7.